There is something on your glass right now that you have been meaning to scrape off. It is green in some spots, brown in others, maybe a little slimy if you run your finger across it, and every few weeks you reach for the magnet scraper and wipe it clean like you are doing the tank a favor. Stop, because what is living inside that film is one of the most extraordinary things happening in your aquarium, and what you are destroying every single time you scrape it spotless is something your fish are quietly depending on. Today, we are going to look at what is actually inside that glass film, who built it, and why, in ways that will genuinely change how you see your tank. And by the end, I think you will understand why some of the most experienced aquarists and aquatic ecologists in the world have made a deliberate decision to leave large portions of it exactly where it is. Let's start with what you are actually looking at. Most people see algae, a nuisance, something the tank would be better off without, and that assumption makes sense on the surface, because it looks messy and it builds up fast and no one told you it was doing anything useful. But that green and brown coating on your glass is not just algae. It is a micro-ecosystem built from a complex matrix of algae, bacteria, fungi, protozoans, and small invertebrates, autotrophs and heterotrophs packed together in layers. Scientists call it periphyton, and it grows on every submerged surface in rivers, lakes, marshes, and, yes, your fish tank. Think of it less like a stain and more like a city, a three-dimensional living city built on every square centimeter of your glass with neighborhoods, food chains, predators, and prey, all operating at a scale too small to see with the naked eye. And here is the thing that most people never realize. Your fish know it is there, and they are using it. That is the open question I want you to hold on to for this entire video. Because the way your fish interact with this film goes much deeper than just nibbling at the glass. And I am going to show you exactly what I mean before we are done. But first, let's talk about what this film is actually doing for your tank, because this is where it starts to get genuinely surprising. The first thing the biofilm does is feed your fish in ways your bottle of flake food simply cannot replicate. Periphyton is rich in polyunsaturated fatty acids, and it serves as an indispensable high-quality basal resource for consumers in aquatic food webs. We are talking about omega-3 fatty acids, the same ones you find in high-end fish food supplements, being produced for free right on your glass. And the nutritional profile of what grows there actually changes depending on how much light hits different parts of your tank. Research on lake biofilms found that the shadier, lower light sections of a surface tend to grow biofilm that is denser in diatoms and loaded with the specific fatty acids that grazers and fish larvae need most. The brighter spots grow more biomass overall, but with a lower nutritional quality. So those dim corners of your tank that you never think about? Those might actually be the most nutritionally valuable real estate in the whole setup. Biofilm acts as a quality protein source, functions as an immunostimulant, and has been shown to improve fish production, yield, survival, and health. Researchers running tilapia trials found that fish with access to periphyton-coated surfaces ate roughly 25 to 36% of the standing biofilm biomass every single day and grew significantly faster than fish without it. A meta-analysis looking across 865 separate experiments found that grazers removed on average about 59% of periphyton biomass, which tells you something important. This is not a fringe food source. It is one of the most heavily grazed resources in aquatic ecosystems on the planet. And it is not just adult fish. Carp fry raised in systems with periphyton-covered surfaces showed significantly better growth and survival compared to fry raised without it. If you have ever tried to raise fry and wondered why some make it and some do not, the presence or absence of a mature biofilm in that tank is a factor worth thinking about seriously. So the film is a live food farm. That is the first thing. But here is where it gets even more interesting. The biofilm is also one of the most effective water filtration systems your tank has, and it is doing it for free right now on every surface you have not scraped clean. Periphyton is a naturally occurring biofilm that provides a rich source of nutrients for aquatic organisms, but it also pulls dissolved nitrogen and phosphorus out of the water column, locks them into biomass, and then hands them over to the grazing invertebrates and fish that eat it. In commercial aquaculture trials, periphyton grown on submerged surfaces removed up to about 80% of total ammonia, nitrogen from fish pond water, while simultaneously producing harvestable biomass. In pilot-scale recirculating systems, periphyton biofilters removed around 32% of input nitrogen and 61% of input carbon from waste and uneaten feed. And during the day, they produced enough oxygen to nearly replace mechanical aeration. Your glass film is a smaller version of that same system. Every time you scrape it clean, you are removing a layer of biological filtration that your tank built over weeks and replacing it with bare glass that does nothing. Now, here is the part of this that I want you to think about for a second, because it connects everything together and it is the thing almost nobody in the hobby talks about. That film is not just algae and bacteria sitting next to each other. The communities inside periphyton encompass a large diversity of organisms, including phytoplankton, diatoms, bacteria, fungi, protozoans, zooplankton, and small invertebrates. There are ciliates in there, tiny single-celled predators hunting other protozoa inside the film. There are rotifers building the structure they want to live in. There are nematodes. There are micrograzers pulling planktonic microbes down from the water column and onto the glass, literally connecting what is floating in your tank to what is growing on your walls. Research has framed this as a full biofilm food web with horizontal food quality gradients and vertical predator-prey chains, meaning there are multiple trophic levels operating on your glass with real predators hunting real prey right now in a film you can barely see. And when you wipe it all off, you are not just removing algae, you are collapsing an entire ecosystem. You are deleting the predators, the prey, the filtration, the live food, and the structural complexity that took weeks to build, all in one swipe of a magnet. Before we get to the wildest part of this, and I promise it is the part you are least expecting, I want to take a quick second because something exciting is happening with this channel. We are working toward 1,000 subscribers, and to celebrate when we hit that milestone, I am doing a $100 Amazon gift card giveaway. All you have to do is subscribe, drop a comment below, and I will randomly pick a winner once we reach that number. If you want to follow the journey and make sure you do not miss the announcement, subscribing is the move. Okay, back to what is living on your glass, because this last part genuinely surprised me. Here is the thing nobody thinks about when they look at their fish tank: microplastics. If you have ever used plastic equipment, plastic tubing, plastic decorations, or even just handled plastic near your tank, there is a good chance microscopic plastic particles have made their way into the water. And here is what research has found. Biofilms act as a sink for particulate matter, including microplastics. The film on your glass is actively trapping those particles, pulling them out of the water column and holding them in place. Research has shown that microplastic aggregation is significantly enhanced by the presence of biofilm and further enhanced in the presence of rotifers. Now that has a complicated side too. Once microplastics are trapped in biofilm, they can potentially move up the food chain as the biofilm gets eaten. But the key point here is that a mature, healthy biofilm is intercepting particles that would otherwise stay suspended in the water your fish are swimming through and breathing. It is doing a job that no filter pad or chemical treatment was designed to do. Biofilms act as a microbial sink for particulate matter and are ubiquitous in freshwater ecosystems, providing key services that promote biodiversity and help sustain ecosystem function. That is not a hobbyist opinion. That is the scientific consensus from peer-reviewed research. So let's bring this all the way back to where we started. You looked at your glass and saw a mess. Something to clean. A sign that the tank needed maintenance. And what you were actually looking at was a self-building live food farm producing high-quality fatty acids your fish cannot get from a bottle. A biological filter pulling ammonia and nitrogen out of the water for free. A multi-trophic ecosystem with predators and prey and structural complexity that took weeks to develop. And a particle trap catching microplastics before they stay suspended in your water column. Every single one of those functions disappears the moment you scrape it clean. That does not mean you never clean your glass. Keeping the front panel clear so you can actually see your fish makes sense. But the back wall, the sides, the hardscape, that is where you want to let the biofilm mature and do its job. A tank with healthy, established biofilm on its surfaces is a more stable tank. It is a better fed tank. And the fish living in it are quietly using every square centimeter of it in ways you now understand that most fish keepers never will. If this changed how you think about your tank, drop a comment below. I genuinely want to know what you thought you were scraping off before today. And if you want to go deeper on what else is living in your aquarium that you have never noticed, the next video is going to cover exactly that. It is worth staying for.